Until a few years ago, the pituitary gland was revered as the so-called master gland of the body because it secretes so many hormones, and several of these act on or target other glandular structures, including the thyroid gland, adrenal gland, testis, and ovary. Further studies, however, revealed that the pituitary gland does not manufacture all of the hormones that it releases, and it has been shown that the hypothalamus, from which the pituitary gland is suspended, manufactures more types of hormones than does the pituitary gland. The hypothalamus appears to be influenced by melatonin, which is released from the pineal body. The pineal body is apparently influenced by the autonomic nervous system. The total number of hormones known to exist has grown from a few to a few dozen. Hormones themselves have been joined by other compounds included under the collective heading of chemical regulators that control many body processes. In general, chemical regulators influence growth, metabolism, and reproduction by influencing certain enzyme levels within their target tissues.
Hi, I'm Mike Shively, and this is Introduction to Anatomy and Physiology. Before we start today, I want to take a moment and review the systems that we've talked about in this course thus far. What was the first body system that we mentioned and talked about? Bryce?
The skeletal system.
Skeletal system. Let's make a list of these. We'll go to the overhead camera. So we've talked about the skeletal system. And when we think skeletal system, what kind of organs do we think of?
The name bones.
Bones. Bones. So the bones of the body make up the skeletal system. We talked about joints, but we can consider them part of the skeletal system. What was the next body system we talked about, Adam?
Muscular system.
Muscular system. And what kind of organs are we talking about there, Adam?
The named muscles.
The skeletal muscles of the body that have individual names. And then the next system. Somebody, anybody. Seth?
The nervous system.
Nervous system. And we spent a bit of time talking about the central nervous system, peripheral nervous system, the autonomic nervous system. And we also talked about a couple of spatialized sensory organs. Spent a little bit of time on the eye and the ear. Well, today we're going to talk about another control system. I say another control system because the nervous system itself is also a system that exerts a lot of control over other parts of the body. This other control system, the next body system that we're going to talk about, is the endocrine system. Now, the nervous system, when it exerts its control, does so by the way of electrochemical impulses. We call those nervous impulses. But the endocrine system exerts its control by way of chemicals that we call what? The general thing. Hazel?
Hormones.
Hormones. Usually when we think of the endocrine system, we think of hormones. Let's put up a graphic here that defines a hormone. It's a regulatory chemical transported by the bloodstream that exerts an effect somewhere other than where it was produced. So we're talking about a chemical that's produced here, carried there by the bloodstream, and then exerts an effect someplace else. Now that's the formal definition of hormone. So when we think of the endocrine system, in general, we can think of the hormone-producing organs of the body. But, to be honest with you, a lot of the organs of the body that produce one or more hormones actually belong to other body systems. I think it's a little bit simpler in an introductory course if we think of each organ in the body belonging to a particular system. So the pancreas belongs to the digestive system, but it also produces a couple of hormones. The kidney belongs to the urinary system, but it also produces a couple of hormones. There are, however, certain organs in the body that all they do, as far as we know, is produce hormones. They have no other functions. Now, hormones are only one of a group of chemicals that regulate processes within the body, and there are some other chemicals that actually have hormone-like actions. It's just that they don't quite fit the definition of hormone that we just put up on the screen. Let's take a look at some of these other chemical regulators. So we'll look at a graphic here. We said hormones are chemical regulators that act on different organs than produce them, okay? Paracrine regulators act on different tissues in the same organ that produce them. And autocrine regulators are regulatory chemicals that act on the same tissue of the same organ that produced them. So these are the kinds of things that we're talking about when we talk about chemical regulators. Now, a couple of general comments about hormones and the endocrine system in general. Hormones are produced in very small quantities. They are very powerful chemicals in that it takes a very small amount of a hormone to exert a significant effect someplace else in the body. The effect that a hormone has is quite fleeting because hormones are rapidly degraded into other chemicals by normal metabolic processes within the body. So produced in small amounts, powerful, rapidly degraded. Those are some of the characteristics of hormones. Now, what kind of chemicals are we talking about? Well, most hormones actually are proteins or polypeptides as far as their chemical nature. Although quite often, when we hear the word hormone, what do we think of? Adam?
Steroids.
Steroids. We think of steroids because these are hormones that are actually abused quite often by bodybuilders and endurance athletes. So we quite often think of steroids. To be honest with you, there are several hormones in the body that are steroids, but the majority of the hormones in the body are proteins or polypeptides. Let's take a look at a graphic that summarizes the chemical nature of hormones. We said most of them are proteins or polypeptides. A few hormones are steroids, some are modified amino acids, and a few are what we call catecholamines. Those words may not mean too much to us, but they mean a lot to a biochemist. Let's go to the overhead camera for just a moment. So we will write the word proteins up here, slash polypeptides. Does anybody remember the difference, technical difference between a protein and a polypeptide? Adam?
The length of the chain of amino acids.
The length of the chain of amino acids. Technically, if we've got several amino acids but less than a blank,
100.
less than 100, we use this term. If we're talking about a chain of amino acids that's longer than 100 amino acids in length, we call that a protein. So these are the same general material, just talking about chain length. As far as the steroid hormones go, there are really two groups. Let's just title this hormones up here, okay? And one of the groups of steroids are the sex hormones. And when I say sex hormones, I'm talking about estrogen, progesterone, and testosterone, those kinds of compounds. The other group of steroid hormones are the hormones produced by the adrenal cortex. And when we talk about the adrenal gland, we'll talk about three groups of these adrenocortical hormones, in fact. The modified amino acids that are hormones, there's only a couple of them. I'm going to write A period for amino acid, modified amino acids. One of them is what's called T3, or triiodothyronine. And the other one is T4, or tetraiodothyronine. Does anybody know what we call these two? If we're collective umbrella, talking about two of them at the same time. Adam?
Thyroid hormone.
Thyroid hormone. This particular one, T3, is the more powerful of the two. T4, the one with 4 iodines on it, is actually sometimes called thyroxine. So another name for tetraiodothyronine, T4, symbolizing the fact that we've got 4 iodines, is thyroxine. So those are the modified amino acids. There's actually some T2 and some T1, monoiodothyronine and diiodothyronine, but the thyroid gland produces those in very small quantities, and they have essentially no biological effect. Then we've got the catecholamines, the 4th group. And these are compounds, they're actually not far from amino acids. They're amino acid-like. Compounds like epinephrine and norepinephrine, which out on the street, those two might be known as what? Adrenaline. Adrenaline. Those are produced by the adrenal medulla, the central part of the adrenal gland. So these are the kinds of compounds that we're talking about when we talk about hormones. You can see it's quite a diverse group. But we've got 4 major categories here. Any questions about that? Adam?
Where do human growth hormones fit into that list?
Growth hormone, it belongs up here. It's one of the proteins, polypeptides. I don't remember how many amino acids are in its chain, so I can't tell you whether it's actually technically a protein or a polypeptide, but it belongs to that first group. Any other questions about the chemical nature of hormones? All right, now let's go around the group, and let's think of organs in the body that produce hormones. I'm going to start right over here and just pick on you a bit. Bryce, name an organ that produces 1 or more hormones.
The thyroid gland.
Thyroid gland. And of course it actually produces about 3. Susan, can you name one?
The hypothalamus.
Hypothalamus produces at least 10 that we know about, at least 10 hormones. Adam?
The testes.
Testis produces testosterone. Coming around this way, Starley?
The pineal body?
Pineal body. We talked about that in reference to the brain a few sessions ago. Actually produces 1 hormone that's called melatonin. So a pineal body, or pineal gland it's sometimes called. Seth?
The placenta.
The placenta. An occasional member of the female reproductive system. If you're pregnant, you have a placenta. If you're not pregnant, you don't have a placenta. And it produces at least 2 hormones that we know about. Hazel?
The adrenal gland.
The adrenal gland. The adrenal gland, when we talk about it in a little while, we're going to divide the adrenal gland into an adrenal cortex, which is the outer part, which produces 3 groups of steroidal hormones. And then we're going to talk about the adrenal medulla, which is the central part of the adrenal gland, that produces a couple of catecholamines, in fact, epinephrine and norepinephrine. Now, we could continue around the circle again, but it gets increasingly harder, does it not? You know, there's a whole bunch of other organs in the body. The small intestine produces some hormones. The heart produces a hormone or 2. The thymus produces a hormone. I think we've already mentioned kidney. Did anybody mention parathyroid gland? I don't believe we mentioned that one at the beginning. I don't think anybody mentioned the pituitary gland, did they? We don't want to forget the pituitary gland. You know, back when I went to high school, we called the pituitary gland the, quote, master gland of the body, because we knew that it produced several hormones, and most of those hormones seem to have an effect on other hormone-producing structures in the body. Now we know that the pituitary gland, although it produces several hormones, doesn't produce as many as, say, the hypothalamus that Adam mentioned. So, and the hypothalamus seems to be under the influence of, at least to some degree, of the pineal body that Starley mentioned. So when you start looking through the endocrine system, we find there's a lot of interconnections and interdependence, where one gland does something, produces a hormone that affects another gland that may produce a hormone, and so there's a lot of that kind of thing. And it becomes quite complex. The disease syndromes that are associated with the endocrine system are basically related to production of too much of a particular hormone or too little of a particular hormone. So basically, or sometimes it's production, maybe when we say too little, perhaps we're producing a hormone, but the chemical nature of the particular chemical that we're producing is altered such that that particular hormone is non-functional. We may be producing enough of it, but it may be non-functional. That happens in a few cases. But When we think of the endocrine system, it's probably best to define it as the endocrine organs plus isolated groups of cells in other organs of other body systems. So endocrine organs plus isolated groups of cells in other body systems. But what is our definition of endocrine organ? Should we define it as any hormone-producing structure? Probably won't work too well. If we do that, then the pancreas and the heart become endocrine organs. And we certainly know that the pancreas, again, belongs to the digestive system. The heart belongs to the cardiovascular system. Let's go to the overhead camera for just a minute. And I want to go to, I want us to make a list of those organs that produce hormones, one or more hormones. So we'll write hormone like this, and we'll put an S after it in parentheses. So it can be one hormone, it can be more than one hormone. And don't do anything else. As far as we know, the list of structures that we want to put on this on our chart here are structures in the body that produce hormones and have no other body functions. Don't do anything else. So what kinds of things, some of which we've mentioned already, what kind of structures? It's a short list, actually. There's only going to be 5 entries on this list of structures. What kinds of organs produce one or more hormones? As far as we know, they don't do anything else in the body. Susan, what's one?
The pineal body.
Pineal body.
Pineal body.
You bet. That's one of them. Again, we can call this pineal gland. And then I'm going to put a dash, and as far as we know, it produces one hormone. Starley?
The thyroid?
Thyroid gland. It produces 2 or 3, depending on how you count them. So I'm going to put 2/3 because you can count them different ways. Seth?
The parathyroid.
Parathyroid gland. I'm going to write GL period since it's such a long word. It only produces one hormone. I kind of like these. The name, you know the name of the hormone this gland produces?
Parathyroid.
Parathyroid hormone. Now that's easy, isn't it? You know, pineal body up here couldn't be the pineal hormone. No, it's got to be melatonin. But nonetheless, what's number 4 or 5 on the list here, Adam?
The pituitary gland.
Pituitary gland. And the pituitary gland actually produces 7 hormones, but releases a couple of others that it doesn't produce. It stores and releases a couple of hormones that it does not produce. So we'll write it like that, 7 plus 2. And who's the last entry on the list here? About adrenal gland. Would that be it?
That's it.
This is a difficult one to put numbers down because the adrenal cortex produces 3 different groups of hormones, several hormones in each group. So I'm going to put down 3 groups plus 2. And we'll explain these numbers and the individual hormones when we come to them. Now, there are a lot of other hormone-producing structures in the body besides the list that we just made. This list is supposed to include just those that produce hormones and don't have any other known body functions at this point in time. To separate these hormone producers from the other structures in the body that produce hormones, let's call these the true endocrine organs. Let's take a look at a graphic that just summarizes what we wrote without the numbers on it. So we'll go to this graphic. When we say true, and I put true in quotes here to make sure that we understand what we're meaning by that, we're talking about hormone-producing structures that, as far as we know, have no other bodily functions. And that would just be this list: pineal body, pituitary gland, thyroid gland, parathyroid gland, and adrenal gland. Now, that aside, let's make another list. Let's go back to the overhead camera and make another list of structures in the body that produce one or more hormones but have at least one other known function. So we're going to say produce hormones put the S in parentheses again. One hormone will do. But do other things. And belong to another body system. They do not, these organs are not going to belong to the endocrine system. All right, who wants to volunteer an entry for this list from some of the things we've probably already mentioned? Adam?
Kidneys?
Kidneys. I'll just write it in the singular form. Produces at least 2 hormones. Susan, can you think of one?
Pancreas.
Pancreas produces at least 2 hormones. Bryce, you got one?
The heart.
Heart produces a couple of hormones. Some of those have only fairly recently been discovered, in fact. Hazel, can you think of one?
The thymus.
Thymus produces one that we know of, a hormone called thymosin. Seth?
Stomach?
Stomach. We'll put stomach on here. I'm going to put it in parentheses. We'll come back to why we're putting it in parentheses in a minute. Produces at least one. You know the name of that one?
Yeah, I don't remember it now.
Anybody know the name of that?
Gastrin.
Gastrin. Gastrin. Okay. We'll come back and explain why we put stomach in parentheses in just a minute. Starley.
The heart.
Okay, we got heart on here already.
We're going to go with hypothalamus.
Hypothalamus, okay. And we could add certainly to this list ovary and testis. I'm going to put them on the same line because we're getting down toward the bottom here. We'll put those on there. Anything else you can think of, or is this just about got it? Susan?
Small intestine.
Small intestine needs to be here. This needs to be about the end of our list since we're down to the bottom of the screen. Okay, so these body structures that we've put on this list produce one or more hormones, but the organ itself belongs to another system. Here we got the urinary system. Here we've got digestive, cardiovascular, lymphatic system, digestive, nervous system, male reproductive and female reproductive systems, digestive system again. Why did we put stomach in parentheses? Does anybody know? Bryce?
Because the hormone that it produces acts on the stomach itself.
It's one of those autocrine regulator, paracrine regulator kind of things. The material gastrin that the stomach does produce actually acts on the stomach itself. And thus, it doesn't actually obey the formal definition of hormone that we put up at the beginning of this session, where we said a hormone is a chemical regulator that is produced here and acts over there. So let's look at our graphic that summarizes this and make sure we got everything on our chart that's on this graphic. I think we got most of them at any rate. Hypothalamus, pancreas, small intestine, kidney, thymus, ovary, testis, heart, placenta. We mentioned that earlier, but we didn't put it on that list, did we? But it belongs here. And then the stomach itself in parentheses because its chemical regulator is not truly a hormone. Now, how do hormones work? In the pre-tape video segment, you heard that they influence enzymatic activity. And if we look at this next graphic up here, it summarizes that exactly. The hormones either cause the production of new enzymes, or they activate enzymes that have already been manufactured but are not in some kind of an active form. They're sitting there, but they need some kind of a boost in order to really do their job of catalyzing. So they cause the production of new enzymes, or they activate some of those that are already present. Now, what I'd like to do for most of the rest of this session today is spend a little bit of time talking about the true endocrine organs, the ones that don't do anything except hormone production as far as we know. And we'll talk about their structure and some of the hormones that they produce. Then we'll worry about some of the other hormones and some of the other organs that are involved in that second list that we made as we come to those kinds of structures in the various body systems that will be coming up in some of our future sessions. So the first hormone, or first endocrine organ that we're going to talk about is the pituitary gland. I want to bring a brain back up here to the overhead camera. If we'll go to overhead, and remember we're looking at cerebral hemisphere with cerebellum down here. I'm going to flip this over. We've got just half a brain here. It's about all I came to work with today, I think. We've got hanging down below the hypothalamus by a thin stalk of tissue here, we've got the pituitary gland. Now I want to show you another word for pituitary gland. So another word that means the same thing is hypophysis. So pituitary gland and hypophysis are synonymous. Don't confuse hypophysis with hypothalamus, because that's another part. In other words, this thin stalk of tissue that you see right here is actually called the stalk or infundibulum of the pituitary gland. It is attached to the hypothalamus. So the hypophysis or pituitary gland is suspended from the hypothalamus. Starley?
I'm sorry, is there a P after the Y?
Oh, hyophysis. So yeah, there is. Yeah, see, I forgot that, didn't I? We'll try that again. Thanks. I think maybe we may have to start this thing all over again. Let's see. Tell you what, let me get another crack at it. I think I can get this right. There we go. Does that look better? Yeah, I think so too. All right, thank you. Now, if we had this thing blown up much larger and could slice it open in a sagittal plane, just as this brain has been sliced more or less on the mid-sagittal plane, what we'd find is that the gland itself, here's the stalk of tissue, and the gland itself is actually divided into kind of a front part and a back part. And this front part is called the anterior lobe. I'm going to write A-N-T, lobe, L-O-B-E, of the pituitary gland. And of course, this back part is going to be the posterior lobe. I'm just going to write P-O-S-T, period, lobe. The anterior lobe up here actually produces 7 different hormones. And we'll take a look at the list of those in just a moment. The posterior lobe, back here in the back, produces no hormones, none. But it stores 2 hormones that are actually produced up in the hypothalamus above it. And those hormones are transported down to the posterior lobe within the axons of some modified cells that are called neurosecretory cells. So the point I want to make right now is the anterior lobe actually manufactures or secretes 7 hormones. The posterior lobe doesn't manufacture any, but it does release 2 that are manufactured up in the hypothalamus. Let's take a look at a graphic that will summarize the hormones that this particular organ produces. These are the pituitary hormones. Growth hormone, this first one, is actually also called somatotropin, as you can see in parentheses there, and quite often it's acronymed GH. when you see GH, and the context is endocrine system or hormones, then we're talking about growth hormone. That particular hormone actually stimulates growth, and it's very important while we are achieving our mature body stature. Overproduction of that particular hormone once we have received mature body size will cause a disease condition called acromegaly. And you remember Andre the Giant, the wrestler, and he played in, what was that movie that
Princess Bride.
Yeah, The Princess Bride. He was in that. At any rate, Andre had some acromegaly, and you get kind of distorted facial features and elongated metacarpal bones and phalanges and that sort of thing. And if you have inadequate amounts of growth hormone, of course, what happens? You don't achieve full body size. You may end up being what we call a pituitary dwarf in body stature size. Thyroid stimulating hormone, also known as thyrotropin, is often acronymed TSH. And its name tells you what it does. So what does it do? Stimulates the thyroid gland. It influences the thyroid gland to produce thyroid hormone. Adrenocorticotropic hormone is often acronymed ACTH. ACTH. And that hormone stimulates the adrenal cortex to produce its hormones. So when this is released into the bloodstream, it travels by the bloodstream into the adrenal cortex, stimulates the adrenal cortex to do its thing. Follicle stimulating hormone is often acronymed FSH. And in males, this hormone stimulates spermatogenesis. In females, it stimulates the development of ovarian follicles. And that's the essence of it, how it was named or why it was named that. Luteinizing hormone is acronymed LH. In females, it stimulates ovulation and a change in the follicular cells from estrogen production to progesterone production. In males, this same hormone is called interstitial cell stimulating hormone. And of course, it's acronymed ICSH. And in the male, the same exact chemical, which is called by a different name in the male, stimulates the production of testosterone by the interstitial cells of the testis. Prolactin is sometimes acronymed PRL. It's also called lactogenic hormone, and it's acronymed there, if you use that word, it's sometimes acronymed LTH. Seems like everything got two names here. It's kind of like Texas, you know, everybody got two names down there, Billy Bob, Betty Joe. Okay. That stimulates milk production by the mammary gland. Melanocyte stimulating hormone, MSH, actually in humans doesn't seem to do much at all. But in some animals, it seems to stimulate the production of melanin by melanocytes, as you might suspect. Now, these last couple of hormones down here at the bottom, oxytocin and antidiuretic hormone, incidentally, is quite often called ADH. You'll see it in the literature as ADH. Those two hormones actually are the two that are produced by the hypothalamus, but actually travel down to the posterior lobe of the pituitary gland, where they're subsequently stored for a bit and then released into the bloodstream from that location. That little bundle of axons that goes down inside that stalk of the pituitary gland to the posterior lobe of the pituitary gland, that little bundle of axons is called the hypothalamo-hypophyseal tract. Hypothalamo-hypophyseal tract. And it, in fact, transports oxytocin and ADH from their site of production up here in the hypothalamus down to their storage/release site. Now, I want to emphasize that all hormones are carried to their targets by the bloodstream. They all get to eventually where they're going by being transported in the blood. And this hypothalamo-hypophyseal tract is the only example of which I'm aware where hormones do at least go from here to there, not to their final destination, but at least from here to there by way of a non-bloodstream route. Any other questions or comments about pituitary gland? I know we kind of blew through that real quickly. Bryce?
On the model, it kind of looks like it hangs down. Is that the hangy ball thing in the back of the throat?
Oh, no. No, this is actually hanging off the bottom side of the brain. That little hangy down thing, you know, that you see when you open your mouth real wide, look in the mirror, that's actually the central part of the soft palate hanging down. It's called the palatine uvula. So it's not the pituitary gland.
Okay.
You're not that exposed yet, Bryce. Starling?
When people say that they have a chemical imbalance in their brain, is that actually within the hypothalamus?
Can be, although chemical imbalance is sometimes kind of a cop-out for we don't know what's going on, so we're going to say we have a chemical imbalance. But there are certain chemicals, certain neurotransmitters that seem to be lacking or too much of or something in those kinds of conditions. All right, let's go to the thyroid gland. I've got a model here that, matter of fact, it's a pretty large model. Let's go to the overhead camera for a minute. I want to show you what I've got here. Perhaps I should orient it like this. This is a front view of the larynx. Here's cartilaginous rings within the trachea. Here's the hyoid bone clear up here. So we're looking at kind of at some structures that are located in the neck. And right down here, we've got on this model half of a thyroid gland. The thyroid gland actually, if we draw one out, actually has two lobes that are kind of connected together by a central constricted area. So this would be one of the lobes over here, left lobe. In this case, this little section right here is called the isthmus, a kind of a skinny area, the isthmus of the thyroid gland, and that over here would be the right lobe. So from a gross anatomy standpoint, there's just those three parts, left lobe, right lobe, and then the connecting isthmus. And I just wanted to show you on this model where it physically sits, kind of just below the thyroid cartilage of the larynx, right on the front of the tracheal region. And then, of course, it wraps around the sides as well. So that's all there is to know from a gross anatomy standpoint about the thyroid gland. What are the hormones that are produced by the thyroid gland? Let's go to a graphic for those. And we'll see that there are basically three main ones, and we've already mentioned two of these, triiodothyronine and tetraiodothyronine. That one's the one that's also known as thyroxine. Together we call them thyroid hormone. Their basic function in the body is to increase the basal metabolic rate. Does anybody know what we mean by BMR, basal metabolic rate? Adam?
If you're sitting at a complete rest, no activity, isn't that your baseline metabolic activity?
That is exactly it. It's how much energy we burn when we're not doing anything. We're completely at rest. In other words, just to be alive takes X amount of energy. Then if you're going to do a hike or ride a bicycle or something else, it takes a lot more, of course. Calcitonin is a hormone also produced by the thyroid gland, and this hormone, as you take a look at that name, you might be able to figure out, lowers blood calcium levels. Now, blood calcium levels are very, very critical to life. If the blood calcium levels get too high, we die. If the blood calcium levels get too low, we die. So we need to keep them right real close to where they need to be, and it's a pretty doggone narrow range, to be honest with you. So it's critical that these blood calcium levels be kept right in a certain area. We've actually got a hormone that watches each end of the blood calcium level. Calcitonin, if the blood calcium levels start getting too high, calcitonin will be released into the bloodstream, and what will happen? Blood calcium levels will be brought back down because of some of the things that calcitonin does to its target tissues. On the other hand, if blood calcium levels get too low, then another hormone will be released into the bloodstream. Anybody know the name of that hormone? Parathyroid hormone. Parathyroid hormone. And parathyroid hormone acts to increase blood calcium levels. So let's go to the overhead for just a minute. The thyroid gland produces, one of the hormones that it produces is calcitonin. And calcitonin lowers calcium levels in the bloodstream. The parathyroid gland produces a hormone called parathyroid hormone. And that increases blood calcium levels. Adam.
Is that mostly through increased and decreased secretion and reabsorption, or is it through actual bone tissue reabsorption?
I don't think the mechanisms of calcitonin are totally understood. Parathyroid hormone, we have a pretty good handle on exactly how it works. It actually has 3 different targets, parathyroid hormone does. It targets bone tissue, and it increases the activity of the bone tissue reabsorbing cells. And those, remember, are called osteoclasts. And as those cells break down bone tissue, then the calcium and phosphorus are released into the bloodstream. Parathyroid hormone also targets intestine, and in the intestine what it does is tend to increase the absorption of calcium from ingesta. And the third target for parathyroid hormone is the kidney, and there the parathyroid hormone tends to reduce the amount of calcium that's lost as urine is formed. Now, I'm not going to be able to show you the parathyroid hormone on a model here because or the parathyroid gland rather, because the parathyroid gland is so tiny. They're just 4 little isolated groups of cells that are buried on the back surface of the thyroid gland. And this is the only situation where we actually have one endocrine organ that's actually in direct contact with another true endocrine organ, is thyroid gland and parathyroid gland. So the thyroid gland is big enough to see. It's got 2 lobes in the isthmus, but the parathyroid gland is actually 4 little isolated groups of cells that are embedded in the back of the thyroid. Starley?
I know that I guess sometimes people's thyroid glands stop working and then they gain weight and they take some medicine which I guess gets that functioning again. Does their calcitonin, is that affected at the same time?
You know, I don't know how calcitonin is affected, but when we have the thyroid kind of thinking out or low production of thyroid hormone, of course what they're taking is actually exogenous thyroid, hormone. And so instead of their own thyroid gland producing it, they're getting their T3 and T4 type compounds from a medicament that they're taking. But the reason that people tend to gain weight when their thyroid gland is not producing adequate amounts of thyroid hormone is because their BMR goes down. In other words, the amount of energy that they're burning just to stay alive gets down to a minimal amount. Thus, if they're eating the same amount as a type A personality individual who tends to hover, 6 inches off the floor, this other individual under low thyroid hormone conditions will gain weight very easily. They're the couch potato types versus the bulimic roadrunner types of human beings. Does that make sense? Mm-hmm. Bryce?
I've got a brother and his thyroid glands swell up, and they told him to take kelp to get more iodine to him. What effect does that have?
As a matter of fact, as you notice, triiodothyronine and tetraiodothyronine, obviously those chemicals in thyroid hormone have a lot of iodine in them. There are certain sections of the country where the fruits and vegetables are very low in iodine just because there's not very much iodine in the soil. Most of us, however, anymore don't have to worry about iodine levels because a lot of the salt that we buy at the grocery store is iodinated. But what will happen in a condition where you're not getting sufficient amounts of iodine is the thyroid gland's not producing enough thyroid hormone. So the thyroid stimulating hormone coming down from the pituitary gland is released in greater quantities, causes enlargement of the thyroid gland. Does anybody know the name of that condition, Hazel?
Is that goiter?
Goiter, you bet. It's called goiter. So that's exactly what's going on there. Some individuals may not process iodine as well as the next person. Maybe your relative sits in or is in a part of the country where there's plenty of iodine, but he doesn't absorb it very well or something. Yeah, Steph?
Is Is Graves' disease a condition of the thyroid gland also?
It is. Does anybody know, we're talking low levels of thyroid hormone or high levels of thyroid hormones? Anybody know? I think we've got, I think it's a hyperthyroidism. Yeah. Let's see. I think you get kind of bug eyes. You remember, what was that movie, Young Frankenstein? Then was it Marty Feldman? And you remember the bug eye character in the movie? I think he had a hyperthyroid condition. He naturally has kind of buggy eyes anyway, you know, and then they emphasize that in the movie. Okay, we talked about pineal body, pituitary gland. We've talked about thyroid, parathyroid. We got one more true endocrine organ to talk about, and that's the adrenal gland. Let me bring up here a model we'll put on the overhead camera. Take a look. Does anybody know in general, what are we looking at here?
Urinary
Yeah, we're
system.
kind of looking at urinary system. Here's some kidneys, some ureters. Here's a urinary bladder. And since we see a prostate down here, this must come from a person named Bruce rather than, you know, Betty. But up here, sitting on top, well, let me pull it down where we see it. Sitting on top of the kidneys, right here and here, these yellow structures happen to be the adrenal glands. Adrenal glands. So there's two of them, a left one and a right one, and they kind of cap the top of the two kidneys. Now, if I take one of these adrenal glands and slice it open, let's stay on the overhead because I want to draw what we'd have. They have kind of a half-moon shape, if you will, a bit of a half-moon or banana shape. And if we'd slice it open, what we'd see inside is there's some different tissue in the middle of the thing. And this outer tissue is called the adrenal cortex. And this inner tissue, in this central part here, is the adrenal medulla. Now, the adrenal medulla, as we mentioned earlier, produces epinephrine and norepinephrine. I'm going to write it epi and norepi. Those are the two hormones that it produces. The adrenal cortex, on the other hand, actually produces three different groups of hormones. I'm going to erase the drawing and list those three groups. So these are going to be the adrenal cortex hormones. I'll just erase the drawing real quickly and write up here. One of these groups is called glucocorticoids. Cortisone, hydroxycortisone type compounds, used in and abused medically for their anti-inflammatory characteristics. And as you can see from the name, they do influence glucose metabolism. Second group of adrenal cortex hormones are mineralocorticoids. An example of one of these is aldosterone. These are hormones that influence mineral metabolism, especially loss of particular ions into the urine, how much of what goes in or does not go in. The third group of adrenal cortex hormones is gonadocorticoids. And these are supplemental sex hormones. All of us men, whether we want to admit it or not, produce some estrogen and some progesterone. And all of you ladies produce some testosterone. And quite a bit of these, quote, opposite sex hormones that are in our bodies are produced by the adrenal cortex. So those are the three general groups of hormones that are produced by the adrenal cortex. Any questions about any of those things? That's kind of a quick blow through of the true endocrine organs, the 5 kinds of true endocrine organs. Yeah.
Is
Adam?
it, if you have a problem with the adrenal medulla, isn't that Addison's disease?
There's Addison's and Cushing's, depending on hyperproduction or hypoproduction of adrenal medulla hormones.
Which one did
Or
President...
cortex hormones. I'm sorry. Did I say medulla? Adrenal cortex hormones.
Well, which one did President Kennedy have?
I don't know.
It was one of the two. Something that's come out recently.
I honestly don't remember. I was a junior in high school. No, I was a senior in high school in '63 when he was assassinated. And I remember that as being a pretty dark day. Our principal came in crying. I'd never seen, a principal was kind of a big, rough, tough guy, you know. And, but I don't know what condition he had. Starley?
What was the name again of the hormone that was produced by the pineal body?
Melatonin. I don't think I ever wrote that one up, probably. We kind of mentioned it in passing and then didn't even talk about it much. While I've got this on the overhead camera, I don't believe we actually looked at it on this brain model either to show you where it was, just to remind you where it was. Here we have a mid-sagittal section of the brain, and here we talked about the pituitary gland and the little stalk of tissue that suspends it from the hypothalamus. The pineal body, Starley, is right back here. It forms the most posterior aspect of the roof of the third ventricle. So right there is where the pineal body is. Interestingly, from a radiographic standpoint, sometimes minerals get deposited in the pineal body or pineal gland, and so quite often that particular part of the brain is radiographically distinguishable simply because of the mineral deposition therein. I want to talk about a couple of other things before we end our session today. One of them is I want to talk about the hypothalamo-hypophyseal portal system. Now, a while ago we mentioned the hypothalamo-hypophyseal tract, and we said it was a bundle of nerve fibers that started up in the hypothalamus, went down the stalk of the pituitary gland, and ended up down in the posterior lobe of the pituitary gland. Well, the hypothalamo-hypophyseal portal system is a series of blood vessels. Let's go to the overhead camera for a moment. And I want this up here to be the hypothalamus. This is the stalk of the pituitary gland. Here's the pituitary gland itself. And there are a bunch of hormones that the hypothalamus produces that actually target the anterior lobe. I'm going to write AL for anterior lobe. Series of blood vessels there's a capillary bed up here in the hypothalamus, and then some small vessels, little tiny venial type channels that come down the outside of the stalk of the pituitary gland, and they end up in another capillary bed down here. So we got capillaries, connecting venules. And what happens here is simply this. The hypothalamus produces at least 8 hormones that actually target the anterior lobe of the pituitary gland. Those hormones are picked up by the bloodstream by entering capillaries that are located in the hypothalamus. Those are the first set of capillaries in what we call this portal system. Then those capillaries drain into larger venial type channels which come down the outside of the stalk of the pituitary gland and end up down in the anterior lobe where the hormones are released and act on their targets. At any rate, 2 sets of capillaries before we get back to the heart. When we talk about the cardiovascular system, we're going to talk about this being a portal system. Well, where does this portal system begin? Hypothalamus. Where does it end? Down in the hypophysis. Thus, it's called the hypothalamo-hypophyseal portal system. Adam.
Is that kind of rare in the body to have 2 capillary beds before it gets back to the
There's
heart
only
like
2
that?
places in the body where this kind of thing happens. The other portal system that we'll talk about when we talk about the cardiovascular system is the hepatic portal system. Normally, when blood leaves the heart, whether it's going to the lungs or going to the rest of the body, doesn't matter, it will only go through 1 capillary bed before it gets back to the heart. So when it goes through two capillary beds in a series, two capillary beds in two different locations before it returning to the heart. That's called a portal system. Anyway, this is one of the portal systems, hypothalamo-hypophyseal portal system. And it transports, again, at least 8 hormones from the hypothalamus down to their targets in the anterior lobe. You have to be kind of careful and not confuse that with the hypothalamo-hypophyseal tract that we talked about earlier, which is a bundle of nerve fibers that transports 2 hormones from their site of production down to the posterior lobe where they're stored and subsequently released into the bloodstream. They target things in other areas. ADH targets the kidneys, antidiuretic hormone targets the kidneys, and oxytocin, the other hormone transported by that tract, targets primarily mammary gland and uterus. What is perhaps the most commonly known endocrine disorder in the American population?
Diabetes.
Diabetes mellitus. Diabetes mellitus. Insulin is a hormone that does what? Lowers blood sugar. It lowers blood sugar. If we have inadequate amounts of insulin, what will our blood sugar levels be then? Think. Be too high. Uncontrolled diabetics, one of the classic signs of that or symptoms of that is high blood sugar. High blood sugar. By taking exogenous insulin in the form of injections, diabetics, those that have diabetes mellitus, can control that. What do we call an individual who produces too much insulin in response to dietary intake of foodstuffs? In other words, there's too much insulin dumped into the bloodstream by the pancreas. Susan?
They're hypoglycemic.
Hypoglycemic. So if we have too little insulin, person has diabetes mellitus. If we have too much insulin being released, it's called hypoglycemia. Any other questions? Bryce?
Is the diabetes mellitus the sugar diabetes?
Yes.
Same thing?
Diabetes mellitus is sugar diabetes.